Continuing our discussion on associative containers in C++ STL, let's see what are map. So these are very useful data structures, and these are associative containers as we are talking about, and these contain key value pairs, and again it's unique. So it's a map and not multi-map. So the keys are unique. So here, instead of, if you compare it with set, in set we had just one value that acted as key. Here we have a key value pair. So first is key, second is value. You can also access this using dot first. So if this is a pair p, then you can write p dot first to get the key, p dot second to get the value, and this key should be unique. Value can be repeated. So if kv already exists and we want to insert another pair with the same key and different value, let's say v prime, then it will not be inserted. And this is sorted. So just like normal set, these are stored in red black trees. So we have a red black tree where the root is black. So it does not, let me draw it in white for black. And then we can have some children, either red or black, but no two continuous nodes should be red. So these are some of the properties you can go through it. So these are the properties of red black trees by which it maintains balance property. So the property that helps it is that the black depth of all the leaves is equal, and no two nodes, continuous nodes, can be red. So if we have a red here, this is not allowed. So this prevents the tree from being unbalanced. So best case can be that it's perfectly balanced, where we have either alternate red and black or all are black. So best scenario would be this. Worst scenario would be that we have alternate red and black. So we have black followed by red followed by black followed by red, and so on. So we are trying to increase the depth. And on the other side, the minimum possible would be, so if we have two black here, then here it should be minimum two black. So this minimum, the closest leaf to the root will be which has all black, and the farthest will be which has alternate. So you can see that it cannot be more than double of this. So it's kind of somewhat balanced only, and its height will be order of log n, even this maximum height. So using this, it tries to keep all the nodes within log h distance, log n distance. So h is the height. So all the operations are logarithmic here. So this is very similar to the set that we had seen earlier. And here you need to include the map. And again, it's sorted just like normal set. But if we see unordered map, there it will not be sorted. It will be implemented using hash table, so it will not be sorted. But here it's sorted. And you can provide a compare function for comparing the keys here. If this key is not of int, string, or some of the primitive types, then you will need to provide a compare. And all the search, removal, insertion take logarithmic time because we are using a balanced binary search tree. And here the height is of the order of log n, and usually implemented as red black trees. And this is the template. We have a key type compare. By default it's less, so it will be sorted in ascending order. And allocator you can also assign. Now let's see some of the main functionality. Size, as usual, you must be familiar with this by this time. It returns the number of key value pairs in the map, or the number of nodes in this tree. Equal to, you can assign an initializer list. So here initializer list will be slightly different. This is the initializer list syntax, and within that we will have pairs, each having key and value. Let's say 5 and values AB, and all will be like this. Then we have these two operators. Add function is used to get, you will pass the key here. Here also you will pass the key. It serves as multiple purpose, this one. You can also access the value. So here 5 has a value of AB and this map is M. So if you print M5, then it should return AB. And at also does the same thing. Only thing is that it will do the bound checking and this one will not do bound checking. So if some key is not present, this will throw an exception. And this can also be used to assign value. So we can write M5 equal to CD. So multiple purpose. So try using this. The more you use, the more familiar you will get. Clear again removes everything. Count, find. Count again, if you write count 5. Since duplicates are not allowed, it will be 0 or 1. In the case of multi-map, it makes more sense. Find, again, if you write find 5, it will return you the iterator to this pair having first element as 5. If it's not present, it will return .end, which does not point to any of the elements. It's a hypothetic iterator pointing to the one position past the last element. And then empty checks whether any key value pairs are present or not. Again, just like our earlier lessons, insert and erase have multiple versions. There are in fact more versions. I have listed the ones which are used more frequently. So you can insert a pair, like we have a map here. Now let's say we want to insert another thing. You pass a pair here. The pair again will have two elements. First one will act as key, second as value. And it will, we will see it in detail. So the second one, we pass two iterators. We have another map and we want to insert from this till this to another map. Then you can pass the iterator to this and one position past this. So this will not be, last one will not be inserted before that. Similarly, you can insert like this, m.insert, and you pass a initializer list, just like we saw here. So we can pass like this, having multiple pairs. Similarly, erase, if you know the iterator, you pass that. If you don't know, you pass the key, it will search and delete. And also you can pass using a range, delete everything from this to this range. Begin returns the beginning of the iterator to the first element or smallest element. If the comparator, depending on the comparator, by default it's less, you can change it. End, one position past the last element. And upper and lower bound have usual values. So upper bound, if this key is present, so upper bound is more than, lower bound is more than equal to. So if let's say this key is present, let's say this value is 5, and we have 2, 3, 5, 10, 15. I'm just writing the keys. There is a value associated with each of them. And if we call upper bound 5, it will return 10, more than this. If we call lower bound 5, it will return 5. But if we call upper bound 7, which is not actually present, then it will return 10. And lower bound will also return 10. So in that case, there will not be a difference, but if it's present, it will make a difference. So as said earlier, it inserts a pair and it returns a pair. So this pair is not related to this one. This pair just indicates that first one will be iterator to the inserted element if it was inserted. Otherwise, if it's already present, then it will not be inserted. So it will return the iterator to the already existing element. And the second one is a boolean, which denotes actually insertion took place or it was already present. So if this second element is true, then that means this was not present, this key, first element of the pair, and it has been inserted. If it was already inserted, it will return false. And this is again the two positions. You have another map you want to insert from there to another map, then you can use this one, and it does not return anything. And this is the initializer list syntax. We will see example of all of these. Similarly, erase have multiple syntaxes. So you have, if you know the position, pass it, it removes the element, returns the iterator following the element removed. So we have 2, 3, 5, 10, 20, and you erase, let's say position is pointing here, and you erase this position. So 5 is gone, so it will return 10. Similarly, you can erase in a range based. So again, POS2 will not be erased. So it's open interval here. And let's say we want to erase from here to 10. So we will pass this one, IT1 or position 1. And 10 we want to remove. So we need to pass this, POS2. And again, it will remove everything. So these all are gone. So it will return this one. And if you don't know the position or the iterator, you can pass the key. So it will first search it and then remove it. So let's see an example of all of these. So first of all, we will need to include the map. And in order to avoid this kind of std::, let's write using namespace std. And we have a map whose key is of type int and value is string. So we will initialize it using initializer list. We will pass some values, some pairs. So let's say we have 10, value is cat. Then we have 20, 20 is dog. And then we have 5. So we are not inserting in any sorted order, but it will be sorted based on key. And 5 is bat. Now let's see the size. And then we use the insert and we will pass a pair. So let's say we have 100 and we have rabbit. So this is some new key. Now let's insert a key which is already present. Let's say 10. And this time value is different, fish. But we will see that it's not inserted because the keys are same. So again, let's print the size, or let's print the complete map itself. Leave size as it is. So this P is pair. So P is pair, so first one is first, and then we have P dot second. And let's give space. And after making these two insertions, we will print the map again. And let's run. So you see that we had 5, 10, 20 and size is 3. Then we inserted 2 more elements, but one of them keys was duplicate. So it just inserted rabbit, and 10 fish is not inserted. Now what we will do, we will erase some elements. So we have seen insertions, we will erase it. M dot erase. So we can pass position or iterator. So m dot find 10. So this will return an iterator which will point to 10, pair containing first element as 10, and this erase will erase that. We can directly erase 10 also, it's not required. It's just to give the demo that this works. And it returns the iterator following the element removed. So this is in sorted order. So 10 is removed, so it should return 20. So let's just print the first element key. That should be enough. So it first, and let's run it. And you see it returns 20 because 10 is deleted, so it returns 20. Now let's comment it out so that we have all the elements intact and we can do further processing. Now let's see how we can erase the same thing using second method. So here we had used iterator. Next time we will just pass the key, and that erase returns the number of elements erased. So let's say int num erased equal to m dot erase 10. So in this case this is not a multi map, so it can be 0 or 1. If 10 is present, then 1, if not 0. So it returns 1, but if you pass here 15, which is not present, then it will be 0. Now let's move ahead. We will see the demo of upper and lower bound. Upper bound equal to m dot upper bound 10. So we have 10, and then lower bound. So this is the iterator. We are just printing the first iterator to the pair. So we will just print the first one, the key. We don't need to print the value, we know the value. And similarly for lower bound. And let's see. So upper bound is 20 because it's a strictly more. Lower bound is more than equal to, so it's 10. But if it's some key which is not present here, let's say 15. So 15 lies between these two. So greater than equal to and greater than both are same here. So both should return 20. Now both are same. So I hope you understand the difference here. Next we have some more insertions. We had seen inserting using pair. Next insert using initializer list. We will insert some negative keys. So none of these are already present, so all of them will be inserted. Because these are negative keys, we have not inserted negative keys yet. Okay, so this is not the initializer list syntax. We should have one more curly braces. So that is the actual initializer list, and these are the values, these pairs. And next, let's print everything again. And now you see these negative values are inserted in sorted order. -30 is the smallest, then -20. Next, let's say we have another map of the same type. Let's call it M2. So AA, BB, 15 is the new one, CC, and let's say one more, 5 DD. And let's say we insert everything from this M2 to M. So M dot insert, M2 dot begin. If you don't want to insert anything, you can pass two values, two iterators. And for the final time, let's print it again, the complete map. And now we have these 15 is inserted, 15 was not there, 10 is not inserted. So 10 cat is still there, but 10 AA is not there. Similarly, 20 BB is not inserted. 15 is inserted. 5 is not inserted. So there are many more functions. You can go through the documentation, the CPP website, and work on the remaining functions if you find them useful. I have just covered the important ones. So see you in the next video.